Another cyclic geometry question. I am Papa with CPAWorks. Now let's look at question 12 of a previous question paper. Now 12.1, use the diagram below to prove the theorem which states there that EFG is equals to EDF. We won't be looking at this question though. We will go to the next question, which is much harder than that first question. However, we are going to do that first question and we are going to send through the solutions by end of business today. So for the time being, we are doing 12.2. In the diagram below, BOC is a diameter of the circle. AP is a tangent to the circle. So remember, BOP is this. So it's a diameter. We saw it. And then AP is the tangent. It's that. And at A here it's right. And you have, and AE is equals to EC. So you have AC is equals to EC. Now you look at the questions. Prove that 12.2.1 BA is parallel to OD. 12.2.2 AOC D is a cyclic quadrilateral. Now you have your 12.2.3 DC is a tangent to the circle at C. Now to answer this question, let me look for a very nice one to start with. I'm going to start off with 12.2.2. AOCD is a cyclic quadrilateral. So they are telling us we must just prove that it is a cyclic quadrilateral. So 1, 2, 3, 4. So how do we start off by proving that this is a cyclic quadrilateral? We can then start our solution off by then typing 12.2.2. Just imagine you forget to type the question number. Now you start off by looking at the information that is given. So your O1, firstly, that's what you look at. Your O1 is this point right here. Remembering that you had equal. So this quadrilateral is contained in something that looks like a kite. So if this is equal and that is equal, it means that this line bisects this chord right here, or this line right here. So this line here bisects this one. So this should be equals to that. So O1 should be equals to O2 as well, right? Now let's look at how we are going to deal with it. So we are going to approach it in this form. O1. Okay, we make our O1 an A. So let's just call O1 A. So if O1 is A, then it means that O2 is also A, right? So we then write C1 is equals to 90 degrees minus what? A. So what does that mean to you? C1 is equals to what? C1 is equals to 90 degrees, which is this angle. Remember, this kite here, this is 90 degrees due to the fact that this bisects this angle right here. It's given. This is equals to that. So this is 90 degrees. The reason for this would be line perpendicular to chord, or red chord, right? Radius perpendicular to chord. So 90 minus your A will give you this C, right? 90 degrees minus A gives you C. Now let's carry on. 90 minus A gives you C. So interior angles in the triangle, like I was pointing out, 90 degrees minus A gives you that. So now you will then look at A2. So for A2 as well, you have the same scenario where again A2, you have this 90 degrees here, right? So this 90 degrees, if you wanted A2, you would say minus that, it would give you that. If there were points, there were actual points. So let's look at it again. A2, it's 90 degrees minus A again. It would give you what? The same thing. So angles, opposites are equal, like I was mentioning that before. So you need to have a point of departure whenever you are answering a question that has a cyclic. So A1 in this regard is equals to A, right? Which is your 10 perpendicular to red, right? So A1, like I was saying, A1 right here is equals to what? It's gonna be equals to C2 as well. So A1 is equals to A, 10 red perpendicular to red. Now let's carry on. A1 will then be equals to what? O1 as well, right? So let's look at it. So A1 will be equals to O1. So this is your, do you see what this is? This is your 10 chord situation as well. So let's go and check it out. So your A1 will be equals to O1. Now you have your AOCD is a cyclic quadrilateral according to what we've proven, right? So converse angles in a same segment. So converse angles in the same segment. So now that we've done this question, I'm gonna quickly jump to the next question, which will be our, probably we will end with question 12.2.1, where we explain BA being parallel to OD. Now we'll go to 12.2.3 very quickly. So 12.2.3. So for 12.2.3, let's look at it again. It says DC is a tangent to the circle at C. Now we are asked to prove that DC is a tangent to the circle at C, right? So the circle at C, now we are going to have to prove that using, starting off with a departing point of B is equals to A3, right? So B, this B is equals to what? A3. Why is that the case? Like I said, so if this is the center here, so these two angles are the same because they are isosceles. This is an isosceles triangle. So these two must be the same because this is radii. So this angle is equal to that angle. So therefore they will make equal angles. So now we'll carry on to the next part of the question. Radii meaning opposite angles are equal. Isosceles triangle, like I was saying. So now we move on to the next part of the question, where now we prove A3 is equals to O1. Now A3 is equals to O1. Let's look at it again. So A3, there you have your A3 equals to O1. Why do you think these two are equal? So if you look at it, these two were said to be parallel. Remember, we had the question one, which wanted us to prove that B1 is equals to OD, right? So these angles, they are alternative angles. Alternative angles are equal, parallel lines. So let's go. So O3 is equals to A3 is equals to O1. Alternative angles equals parallel lines, like I told you. Now O1 is equals to C2, right? O1 is equals to what? C2. Let's go and look at it. O1 is equals to what? C2. Now why do you think O1 would be equals to C2? Now this again is another very important thing that you should note. Angles in the same segment, they are equal, right? So you should always note that part of the question. And if you are struggling, please hit us up. Therefore your C2 is equals to B, and as a result you have your DC is actually a tangent to the curve. Converse tangent tangent chord, right? So now we are going to answer what? 12.2.1, as I promised, where you have your BA parallel to OD. So you have your BA parallel to OD right now. So now this is what we are answering, right? So we worked our questions from the middle to the end. Now we're going to the beginning. Now I wanted you to answer like that because you are preparing for your exams. You never know how they are going to align the questions. So I'm giving you another way of thinking, meaning a different perspective from the norm. So now let's go right ahead and answer question 12.2.1. BA is parallel to OD. Now looking at this question, BA is parallel to OD. Firstly, we need to prove that BAC, right, is equals to what? 90 degrees. So if BAC is equals to 90 degrees, the angles in the semicircle, as you can see, BAC is equals to 90 degrees. Angles in the semicircle, we can't disagree there. This is a diameter, so we have an angle in the semicircle. Remember that. If we have the angle in the semicircle, and then we have another thing that we have to look at, which is OD. Remember, so we have the angle in the semicircle right there with BAC. Now we will look at E2 equals to 90 degrees. Now why is E2 equals to 90 degrees? The line drawn from center to midpoint, right? Line drawn from center to midpoint. So line drawn from center. So this line bisects this point right here. So this chord is bisected by this line that is drawn from the center. So therefore, it's already 4 marks. Therefore, BAC is equals to E2. And that actually means that the question that we are answering, BA is parallel to DO, is true. Corresponding angles and alternative angles are equal, right? So we know that for a fact. Now we are done with this question. Please subscribe to our channel for more helpful videos on Euclidean geometry and much more.